All right, let's talk number 9 from 1.2. We are asked to use the squeeze theorem to provide evidence for the limit as x approaches infinity of 1 minus the cosine of x over x squared. So let's remember the squeeze theorem. The squeeze theorem essentially is about taking your function at a particular value and, in essence, squeezing it between two other limits that may have the same limit at that particular value. And what we want to show here is that the squeeze theorem can be extended not just to a constant value, but actually to x as approaches infinity. So it will apply as x grows large. So the first thing to do is to find our two extra functions. In essence, we want to find our g of x and our h of x that this function lies between. So let's begin with the cosine of x, and let's recall that cosine of x lives between the values of 1 and -1. And I think then it follows that it's true that negative cosine would also live between -1 and 1 as well. We would, in essence, just flip-flop the upper and lower limit of the bound, and we would still have a 1 and a -1. And I put that negative sign there because we're trying to build this function 1 minus the cosine of x over x squared. So next we need that 1. So let's add 1 to each of the pieces of this inequality. And that gives us now an inequality of 0 is less than or equal to 1 minus the cosine of x, which is less than or equal to 2. And then finally, we can divide each of these pieces by x squared. And now we have a triple inequality that says our function, which we're calling f of x, lives between 2 over x and 0 over x squared. So I believe we are ready to come to a conclusion with the squeeze theorem, as long as the second piece of the squeeze theorem is true. So what is the limit then as x approaches infinity of the function on the lower bound, which is, of course, 0 as x approaches infinity? The limit as x approaches infinity of 0 is 0. What about the limit of the upper function? The limit as x approaches infinity of 2 over x squared. And by graph, we can show that this is also 0. So now we have the two conditions of the squeeze theorem true, and we can give our answer. If f of x is equal to 1 minus the cosine of x over x squared, then 0 is less than or equal to f of x, which is less than or equal to 2 over x squared, and the limit as x approaches infinity of 0 is equal to the limit as x approaches infinity of 2 over x squared, and both of these are 0. Therefore, now here's where we give our answer. The limit as x approaches infinity of 1 minus the cosine of x over x squared is that same limit value, 0. And let's just prove this, by the way, with a graphing calculator and make sure everything here makes sense graphically. Let's graph y equals 0. Let's graph y equals 1 minus the cosine of x over x squared. And let's follow that up with 2 over x squared. And let's take a look at this. So here's our first function. Here is the function in question, and it lives above 0. I agree. And here comes our last function, and I think we have it. I actually want to zoom in a little bit over here to the far edge of this graph so that we can see for sure. There's the lower limit, 0. Here's our function, which lives slightly above. And here comes 2 over x squared, which is above that. And we have squeezed our function 1 minus the cosine of x over x squared in between two other functions. Both those other functions have a limit of 0 as x goes to infinity. Therefore, since our function is squeezed in between, it must have the same limit also. Hope this helped.